Starlink Constellation. It's an infrastructure for a space-based internet system. In today's world, the fiber optics cables are laid under the ocean to transmit the data. But there are still some places which has limited or no internet access. To solve this issue, SpaceX needs 42,000 satellites traveling at a speed of 27,000 km per hour, 550 km above our heads. A small mistake in this will completely ruin our night sky and make space inaccessible by the human beings. Anyone looking at this might think like there is a high chance of collision, but there is an order. The order in which Starlink Constellation was built. Starlink Constellation consists of 5 cells. In that, cell 4 and cell 5 are almost similar to that of cell 1 and cell 3. So for easy understanding, let's focus only 3 cells. These cells are classified based on the orbital inclination from its equator and its altitude. Starlink Constellation uses 53 degree, 70 degree and 97.6 degree inclinations. So whichever satellite lies in the 53 degree inclination at 550 km altitude belongs to cell 1. Similarly, 70 degree inclination at 570 km altitude belongs to cell 2. And finally, 97.6 degree inclination at 560 km altitude belongs to cell 3. In order to cover the entire Earth, each cell has a numerous orbital plane inside it. For example, cell 1 has 72 orbital planes which are equally spaced around the entire Earth. And each orbital plane consists of 22 satellites which are spread across the entire orbital plane. Here each cell has its own orbital plane count and satellite per plane count. All these cells are combined to form the final Starlink constellation. Let's build this in the real world. SpaceX usually sends 60 Starlink satellites in a single launch. But each satellite weighs around 260 kg. By simply stacking one over the above, will crush the bottom satellite. So each satellite has 3 standoff. They are higher than the actual satellite. So while stacking, these standoff will take the load, not the satellite. And usually 30 satellites are stacked on each side. SpaceX uses special tension rods on 4 sides to hold them securely. Finally, the fairings are enclosed and the launch happens. At space. Now the second stage will start to spin. This spin is necessary for the satellites to distance themselves from each other after deployment. Now all the 4 tension rods will be released. Because of initial spin, now the satellites are automatically distanced themselves from each other. Hereafter, the second stage will be deorbited into the Earth atmosphere. Once the spacecraft are distanced themselves from each other, the solar panels are deployed. Now the satellites are in the low drag configuration. At this stage, if there is any faulty satellites, they will be deorbited. Remaining satellites will fire its Krypton thrusters and reach 350 km parking orbit. From here, the delicate placing of satellites in its respective orbital plane begins. Let's assume SpaceX wants 20 out of 60 Starlink satellites in the same orbital plane. Now these 20 Starlink satellites will fire its thrusters at a specified time interval. So they all end up in the different position at 550 km final orbit. Now the solar panels are erected to generate maximum power. Side parabolic antennas are deployed and the satellites are ready for its operation. Now the SpaceX wants next 20 satellites to a different orbital plane. For that, they simply wait in the 350 km parking orbit until the fat Earth theory naturally twists the orbit for free. After the orbit is twisted enough, now the next 20 satellite will fire its thruster at a specified time interval. So they all end up in the different position at 550 km final orbit. Here the inclination is determined by the launch trajectory and the plane change can be done by Earth for free. SpaceX continues this process again and again and again and again to form the final Starlink constellation. Wait. We'll be giving our 3D assets to you. So head over to our PayHip store and grab yourself one. And if you are a Patreon member, you'll get one 3D asset for free every month. Links are in the description.